Hello. So today we are going to actually start trying to move the objects with network behavior, and we're going to try to change some stuff around so that we can get to actually play a game, so to speak, with different players. I am purposely going to do this the wrong way so you can see kind of trial by error, a trial by fire, to see how you could get up to a place where you could control your character. All of these different scenarios you may encounter and probably will encounter during your own work, so this is why I think this will be a useful experience, although it's a little bit slower than I would normally present the material. So going off our tutorial we had last time, let me just get rid of that, I don't need that anymore. I'm going to create a new prefab and my network player bad example, and basically it's going to look just like the prefab we had before. Except it's going to have a rigid body, does not use gravity, and I'm going to have a different script, and I'll show you the script in a moment. Everything else is going to be the same at the moment. The rigid body, not using gravity, and bad example. So I go to my bad example script. I was basically approaching this as if we're going to try to write our code just like we would a single player game. So here we're going to have our rigid body variable. We're going to find our rigid body on start, and then during update we're just going to get the two inputs and set the horizontal and vertical speed to the x and z vector. So we're going to go left, right, forward, and back, and we're going to kind of a naive approach to making our character move. Funny enough, this will actually work differently than you probably expect. So this is, again, this is basically just taking a single player script and trying to make it and trying to put it on a network. If you pause it, if you need to look at this. All right, moving on. So like I said, I'm going to have that script right here. If I go up to my network manager, I can then change my player prefab. This is the thing that gets spawned every time a player is created, and I can add my network example bad instead. So instead of using what I had before, I'll be using this bad example. So we're going to go ahead and build settings, or build and run. I guess I didn't have to do that. Build and run, test, that's fine. Yes. And we'll play it, and we'll play this. Oh. So here we'll host, and then we'll go down here to our other one, and we'll connect. So it's, remember that this is the client and this is the host. So on the client side, I can move, and you'll see that I'm moving both of the balls. Both of the players are moving with me. Unfortunately, nothing's moving over here. If I click the server side, I can move both of the balls again, just like the client side, and if you look, they're completely in a different position than the client side. So this is an example of desynchronization, where the game states have changed to such a point that there's really no point in playing the game because no one can tell what's happening. Now, the reason this is there's those two issues that are really an issue right now. One, we don't have any rules set for what information we want to transfer, and two, we're not determining which character is ours. So keep in mind, this is a very important thing to think about. Keep in mind that this code is going to be running every frame on every client on every object. So regardless of whose character it is, currently I'm getting the input and I'm setting that velocity. Again, this code is going to run on every machine, on every object on its own. So this is where you have to start thinking very carefully about how you want to design your code. The second problem is, like I said earlier, we haven't determined what we want to network. So we'll just close this real quick. Well, obviously in this case, the thing we would think we were going for would be the position. Seems like the primary game state that we want to keep track of. So what we can do to fix that, the first issue, is now go to our bad example, and what we can do is go down and add a component, and network. And here we have this thing called network transform. Now this means that the position will be synchronized through the network. It also will add another issue that we'll have to deal with in a moment, but this is the first step in getting this to work. So now the network transform will be synchronized through all the clients and all the servers. If I click on it, I have several different options. Here, by default, it sets that rigid body 3D. I can also synchronize it on transform, a 2D, or I can do a character collider. Here, notice that I am not synchronizing angular velocity. You may or may not need to do this, depending on what your app. In this case, we do not need to do it, but in some applications you would want to. And we have this thing called interpolation movement. One thing I would recommend and warn you against is synchronizing out the transform. The rigid body itself can give you interpolation and make this appear more smooth. So if you look at this, we have interpolate and extrapolate. You can play around which one you think is better. I think generally interpolate a little bit better, but I have seen some cases where extrapolate looks a little smoother. And what this is going to do is it's going to try to predict in between frames what speed the ball's going and try to predict where it's going to be. It's actually not super useful in a single player game because generally your computer is going to be fast enough, generally. But down here on the network transform, it actually can help a lot. So we can play around with these variables. I'll probably come back to these variables a little bit, but I usually keep interpolation on with the rigid body for smoothing it out. Remember that you are only going to get about 9 hertz or 9 times a second transfer rate. So that means at 9 points in a second, your character is going to update its position, which can look kind of choppy. So it can look like kind of jerky as the character is moving across the screen. Not that bad, obviously, but something similar to that. And so by interpolation, you can smooth this out a little bit. So we'll come back to this. But by default, this should be fine. So now we've set the rule that we want to watch the game state of our player object, right? So maybe that will fix it. So let's go here, File, Build and Run. Made a LAN host and LAN client. There we are, both there. Now if I try to move the client, nothing happens. So I've completely broken the client. The client can't play now. If I try to move the server, they both still move. So at first glance, I would think I'm going backwards. Like this is going the opposite direction that I want to go. Actually, it's not, but it's very misleading. This is one reason I'm doing this tutorial this way, is to show you the different situations you might encounter. What's happened here is by setting this rule that we're going to be following the transform, the object now has a certain authority. And if I click down here, if you look, we do not have local player authority set, therefore the server has authority. Therefore, the server is the only thing that can move or change a variable that's being synchronized if I do not have this clicked. If I have this clicked, then I can set this, the local player can set it. But again, we're not going to do that. So the server is the only thing that can actually change the value on a synchronized value. That means the only thing that can actually move the said object is the server. So how do we get past this point? Well, remember we talked about it briefly. We have the command. So what we're going to do now is we're going to go and so instead of doing this, we're going to use the command. If you did the reading on the internet, the assigned reading, you'll remember reading a little bit about this. But I can state a command like this. So. And what this is telling me is this is going, I can make it public, it doesn't have to be public. This is going to be called on the server. And I can call it as a normal function on the client but it has to be, it's going to go and run on the server. So here I go CMD. One keyword, the commands have to start with CMD. I always put underscores. You do not need the underscore, but you do need the capital C, lowercase md. And what I'm going to do here is take in two floats, the vertical h and the vector horizontal and vector float from my move. Now the cool thing here is this is going to be on the server. Presumably, I know this is actually naive, but presumably this will be on the client. So all I have to do here is just set, basically copy this command. And bring it down here. And here, all I have to do is call command move me. Whoops. And I can send in my VH and VF. So I've literally changed nothing in the logic, but now I'm calling this command. So if this is on the client side, which we'll talk about in a moment, I call this command, and then I'm going to set the velocity, but this is going to be on the server side, so that should be okay. And so now it should work. The other reason that you say, well, what's the big deal? Why not make it local player authority and just set it there and save us some time? Well, I could also check and make sure it was a valid input if I needed to. Otherwise, I mean, I could potentially send in, vector horizontal is 1,000, and that could break my game. So what I could do here is I could say if VH is less than or equal to 1, and sorry, been in the wrong language for too long. And VF is less than equal to 1, then go ahead and do this. And this should be true because I'm just taking the raw axis values, which should go from 0 to 1. So this should be true. It's 1 inclusive, so I have to make sure it's equal. But now I know if I get a vector or a velocity, horizontal velocity forward, that's like 1,000 or some enormous number, then I know that this is false, that this is an invalid number. And actually I should say absolute value to be fair. So if the absolute value is less than or equal to 1, then we know it's a valid input. And this demonstrates in some form the importance of using commands, because the client is freely giving a command to change a game state, but the whole point of having the server authority is to make sure that the game state is valid. So now it should work, right? Well, we'll see. We have one more tiny little problem. So here we are going to file, build, run. And run here. So here again, once again, we'll land host. And once again, we'll land client. Okay, you ready? It's going to work now. All right, it worked. Okay. So the client seems to be working. A little bit of lag, but not too bad. And actually, the biggest part of the lag is probably happening because we're running this inside the editor. That adds a lot of lag to the Unity's performance. Now we'll do server side because this is working too. But you notice I'm getting a little bit of weird aliasing, like as if it's trying to move the other ball. In fact, it is kind of trying to move the other ball a little bit. See, it's trying to move it slowly. Well, so what's going on here is I have one more issue, and that is I am still running that update code. Let's see if it didn't give me any warnings. I thought it would. But I'm still running that update code inside my function here. So both for the server object and the client object, this code's being executed on both clients, which means that I am sending in a command to have the server change this velocity on each individual object. For some reason, the client was not able to send in a command for this. I think it's because it's built-in protection, but to make it the server actually can do that if you're not careful. So the server could actually call a command for the client if it wasn't careful. So to fix this, the other thing is do is proper. To say if is local player. Now this is built into the network behavior, but if this is true, this means this player, it represents me, represents the person on the machine. Now only the local player will get the input and send a command, and the server will only move the command if it's the local player. So we should have that little jitter we saw on the server side when we were moving it here. Oh, which apparently it died, so it should be gone. So let me remake that real quick. And host, play, and client. And now the performance should be much better. So here, now you see, I'm not seeing any jitter. It's hard to see on this screen, but I don't see any jitter, so I think we're okay with the client. And then if I go to the server, notice the client and the server are synchronized. Notice I'm no longer trying to push the other ball. Only the server side is moving, and that's because I have the isLocal checked. So that is a demonstration of kind of doing it the hard way, of trying to get two characters to be able to move around and have the synchronized position. But I wanted to show you what could go wrong and what different things that can happen. Another thing to be aware of real quickly is the start is not a true constructor, but even if it was, the start can sometimes have a weird race condition. So for example, perhaps the most classic is the client has some sort of event here, or some sort of get variable or get component here. On the server side, the start will run first, everything will be fine, and then it will spawn the object across the network. On the client side, because the object spawned, it may actually be running an update cycle before it runs the start. So you have to be very, very careful with what components you initialize here, because otherwise it may not exist down here. In this case, it's fine because only the server is using my rig, but you can have some really interesting race conditions. That will conclude this video, and next video we'll talk about some other stuff, sync vars.